architect or a system designer of these systems, your decisions are always a balance, right? There's a balance between the performance and maybe the amount of memory you're going to use for your application. There's a balance between how flexible your application is versus how much code you had to write to give you that flexibility, right? So there's always this balance and this trade-off. And as you're looking at resource utilization, certainly that's always a balance in the decision-making process. Okay, so one of the things, there's some examples of how you configure and how you use this middleware. And you can make design decisions about it that really affect one way or the other, how much memory you're using, or maybe how the CPU is used, how the network is used. So this example talks a little bit about architecture. DDS has this publish-subscribe architecture. You define the data types that are used, and you define the topics that you're going to use for communication. So this example talks about, it's just a simple application that publishes shapes, different shapes of different colors. So maybe your data type is very generic. You have just one data type that's a shape, and as part of your field is what kind of shape it is, and another field is what kind of color it is. Well, now you just have one topic, and all you need is one data writer and maybe one data reader to write whatever kind of shape you want to write and read whatever kind of shape you want to read. And another option, certainly another way to architect this, is to do multiple topics. So maybe you have a writer that knows how to write squares, and a different writer that knows how to write circles, and a different writer that knows how to write triangles. So in order to put together your application that's required to write these three shapes, on one case, you have fewer data readers and data writers to get the same idea across, and over here you have more data readers and data writers to get that idea across. Well, this is going to affect how much memory is used. First, for creating these local entities. I have to create more entities. I have to use more memory to do it. And then also for discovery on the wire, because I have to keep bookkeeping about all of my matched peers out on the network. And if I have more peers that I have to keep track of, then I have a little bit more bookkeeping involved there. So just one example of how design decisions can impact how much, in this case, memory is being used. All right, let's see. I'm going to go through just one more example here quickly. So this talks about defining your data types. And so looking at that same example, maybe we decide that our color is just a string. And so now we have to decide, is it an unbounded string, because I could have red, which is very short, or I could have purple, which is a little bit longer, or I could have, I don't know, a very long sort of color name. Or do I bound that and make it a bounded string? You think maybe this is not a big deal in design, but it can be a big deal if we're talking about writing a lot of these data samples. Well, this over here is quite nice because it's bounded, and it means what we can make some decisions. We know exactly how much memory we're going to be using. But once we multiply this out, we're using quite a bit of memory to allocate the samples or the data that we're going to be reading or writing. Whereas over here, if all we have to allocate is what we actually use, then a lot of times, well, we can't pre-allocate it ahead of time. We have to kind of do it as we're running. But we tend to save space because we're never allocating more than we need. And so we look at here in this example where we have, I forget how many we have. I guess we have 100 samples going on here. Then it can make quite a bit of difference as far as how much runtime memory is being used just to hold 100 copies or 100 instances of these samples. All right, so this is kind of obvious. Early insight allows for better system planning. It's also kind of a challenge too, right? In order to do this, you need to have the tools available to be able to plan, to be able to estimate, right? You're going to put the system together, and I need to be able to estimate if I have this architecture with these kinds of publishers and these kinds of data, how much memory should I expect that to take up, and how much processing, how much CPU can I expect that to take up. So you need the tools in order to be able to plan, and then you need the tools to be able to measure as you're running and as you're implementing to see if you're staying within your expected design, and to be able to make changes if necessary. So there's basically two ways to do this. Assuming that you're getting a middleware component that's a commercial component, you don't have access to the source code, so all you have are the specs on it. You can measure the utilization from the outside, and this is using operating system type tools, right? You're doing a PS, you're doing a top, you're looking at the kind of from the outside of the process, how much memory, how much CPU is being used. And then you have measuring from the inside, which is obviously going to give you a finer grain of detail and more information as you're executing and as you're running as to what's being utilized. And this is an example from DDS, and I think this is an example of DDS looking at memory, where in this case this DDS product has you can run it and turn on instrumenting of memory operations. So what gets logged then and recorded is every memory allocation and deallocation with a tag of when it happened, a timestamp, and where it happened. It was in this data reader, or it was in this topic, or it was in this data writer, which really gives you the ability to look in and go, wow, you know, my publisher, this publisher over here, this writer of data is taking up a great percentage of my memory, and why is that, and can I do some reconfiguration or maybe a little bit different design to change what's going on. And that's much harder to do if all you have are the outside tools. I'm getting close to time. All you have are the outside tools for the operating system to look at what a whole process is doing. It just gives you better tools.